Hi, welcome back to another video. So today we're going to just quickly go over absolute values and solve some exercises while we're at it. So the rundown about what you need to know about absolute values is that if you have an absolute value, so you have the absolute value of x, what does this mean? Well, it means that you just take the actual value, so the distance from the starting point. So let's say we have a number line and we have here the starting point, which is 0. And then we have 3 over here and minus 3 over here. So the distance from the starting point is 3 in each case. It just dismisses the size. So the absolute value is basically just the magnitude, but it ignores the direction. So here we went right and here we went left. And in each case, we've dismissed when we take the absolute value, it's 3 in both cases, we've just dismissed the direction. Okay? So there are a few rules that are at play here. First, the magnitude cannot be negative. It can be at least 0. That's the lowest it can be. But it cannot be less than 0. So the first rule is that the absolute value of negative x is the same as the magnitude of x. Okay, because we're just looking at the size, we don't care about the direction, and the negative sign implies direction. Second, the absolute value of x is always greater than or equal to 0, so it cannot be less than 0. And then we have the so-called triangle inequality, which means that if we have a plus b in the absolute, that's less than absolute A plus absolute B. This is a very important thing and it's quite easy to prove. If A and B are both positive, then they're equal. Or if they're both negative, then it's also equal. But if we have varying signs, so for example, A is greater than 0 and B is less than 0, well then their sum would be less than A, and that would be less than absolute A plus absolute B. It's quite intuitive. You can just take a few examples and try it out and you'll see it holds up. And that's basically the things you need to know. The fourth one, it is the distance from starting point. Last one that we kinda can mention, it's not really all that important, is that it's equal to 0 if and only if x is 0, okay? So again, here you see the logic symbol and we've explained why they're important in the logic video. So let's get started with this and let's solve some exercises. So these are basically the theory that you needed to know. Here's the exercise. Let's say we have 2x minus 1 equals x, so and 2x minus 1 is in the absolute value. What you need to do is first, write the condition. You always write the condition for when is the absolute value greater than 0 and when is it less than 0. So we can go two ways. 2x minus 1 is greater than or equal to 0, or 2x minus 1 is less than 0. Oh, and I don't think I actually mentioned this, which is the most important thing. Absolute value of x is defined like this. X if x is greater than or equal to 0 and minus x if x is less than 0. Okay? That's how it's defined. Basically, it's the function of absolute value is defined in this way. Okay? It doesn't really matter if we were to use negative here, like that if we said it's negative x if x is less than or equal to 0. Just for simplicity's sake, we use this one more commonly. But this would also be correct, and there would be nothing wrong with it. Okay, so yeah. Let's see. If 2x minus 1 is greater than or equal to 0, well, let's solve this inequality first. 2x minus 1 is greater than or equal to 0. 2x is greater than 1. And x is greater than or equal to 1/2. Okay? So that's our condition. And this will be important because when we get the solution, we're going to have to check the condition to see which option is even possible. For example, you might get that the solution to this equation is x equals minus 1. And then we would write no solutions because we said, well, in order for this to be true, x has to be greater than 1/2. And we got that the only solution is x equals -1. So starting with this one, we have if x is greater than 1/2, then 2x minus 1 is greater than 0, and we don't need to put a negative sign in front of it. We just write 2x minus 1 equals x, and then solve the equation, so x goes to the other side, so we have x equals 1. And this is okay, because we have that the solutions, the possible solutions, should be greater, so on the right side of 1/2, and 1 is on the right side of 1/2. Okay? So that's valid, that's okay. We can say that this is an okay solution. Now, if 2x minus 1 is less than 0, then say, just flipping the sign here, we would get x is less than 1/2. And let's see, if if x is less than 1/2, then this would be less than 0, so we would have to put a negative sign in front of it. So minus 2x minus 1. So we just replace the absolute value with parentheses and we add a negative sign in front of it. Equals x minus 2x plus 1 equals x minus 3x equals minus 1, x equals 1/3. Okay, so we just solved the equation here. Here x went to this side and changed its sign, so it became minus x, minus 2x minus x is minus 3x, and 1 went into the other side, so from plus 1 we got minus 1, and then we just divided by minus 3. Okay, so we got that when x is less than 1/2, the only solution is x is 1/3. Is 1/3 less than 1/2? Yes, it is. Okay, so because this is 0.3 periodical and this is 0.5. Okay, so this is okay. This solution is also valid. So we would write that our solutions are, and we would write 1/3 and also 1/2 or 1. Okay, so these would be our solutions, 1/3 and 1. Okay, or rather you could also write it like this. So x equals, x1 is 1 and x2 is 1/3. Okay, so these would be our solutions. Now, what about the next one case? So we have here x minus absolute value x plus 1 is equal to 0. We're just going to move this one a bit down so we have more space. So here and then here. Again, we're just going to separate it into two cases. So this is our absolute value. So we want to see when x plus 1 is greater than or equal to 0. So that is when x is greater than or equal to minus 1. And in that case, we can just remove the absolute value and don't add anything. So we would get x minus, and then this would be parentheses. Well, whenever you replace it, so if you were to get the thing inside of absolute value to be less than 0, you would replace the absolute value with parentheses and add a negative sign in front of it. And if you were to get that the value inside the absolute value is greater than 0 or equal to 0, then you would just replace the absolute value with parentheses. So here you have to replace it with parentheses in each case, but in one case you add a negative sign in front of it. So we would get x plus 1 equals 0, so x minus x plus 1 equals 0, and we would get 1 equals 0. So here we got an impossible situation. So in this case, for x being greater than minus 1, there are no solutions. Now let's see what if x is less than minus 1. Then in that case, we would get x minus, and then we said that we're going to replace the absolute value with a negative sign in parentheses. So minus x plus 1, okay? And we know we can't have two minuses one after the other, so we'd have to place parentheses here again. Or we just know that it would become a plus sign here. So we would get plus x plus 1, okay? Equals 0, and in this case we would get 2x plus 1 is 0, and x is minus 1/2. So, when x is less than minus 1, the only solution is x is minus 1/2, which is greater than minus 1. So this is also not possible, okay? We're just gonna write here x here and an x here. So this exercise has no real solutions, okay? No real solutions. It might have a solution in the complex numbers, but in the real plane, there are no solutions. Now we move on to the next one. So, for example, we have 3 minus x. It's the same procedure. Here you can kind of already see though what it's gonna be. For example, in this case, you might notice that, okay, so to get 1, the value here is going to be either plus or minus 1. 3 minus x, how can I get it to be plus 1? Well, I'd have to make x be 2. Okay, so x is 2. Or I can make it be minus 1, and that way I would have to say x is 4. So you could basically solve an exercise like this really quickly, but generally speaking, teachers don't like these types of solutions, so I would advise that you go through the procedure mentioned here again. Now let's take a new one. What if you have two absolute values? Well, then you just separate the case into two parts, or rather you're gonna have 3 parts. So first, we're gonna see what happens. We're gonna take the number line. We're gonna see when each one of these is equal to 0. So if x minus 2 is equal to 0, then x is gonna be 2. And if x plus 1 is equal to 0, then x is gonna be minus 1. Then we're gonna draw a number line. And we're gonna write these values on the number line. So minus 1 and 2. Okay, so if x is going to be more than 2, so here, then we're gonna have, for example, 3 minus 2, it's gonna be positive, okay? So in this case, x minus 2 is positive, and x plus 1, so for example, 3 plus 1, it's also gonna be positive. X plus 1 is also gonna be positive. Now, if x is gonna be less than 2, so you see we've switched signs here, we went to this field here, then one of them is gonna go from plus to minus, or from minus to plus, basically. And it's gonna be the one whose number it is here. So, for example, x minus 2, we have 2 here. So this one's gonna change signs here. So we're gonna have x minus 2 is gonna be negative, and x plus 1 is still gonna be positive. Okay? And then, once we switch signs again, both of them are gonna be negative. So x minus 2, it's gonna be negative, and x plus 1 is also gonna be negative. And then you just solve each case individually. So let's say we're gonna start with here. So when x is greater than 2, okay? When x is greater than 2, what's gonna happen? Well, if both of them are going to be positive, okay, so we're just going to write greater than or equal to 2, let's say that. Okay, so yeah, it can also include this point, because if x is 2, then we're going to have 2 minus 2, okay, and it's going to still be positive, so it won't matter. X is greater than or equal to 2. We remove the absolute values here, and we don't add anything, okay? We could add the parentheses, but we would just remove them in the next step, so I'm not going to add them here. X plus 1 equals x minus 2. Okay, we can reduce the x's on each side, and we get 1 equals minus 2, so this one has no solution. Okay, has no solutions. So this one is a no-go. What about this one? So when x is going to be between minus 1 and 2. So minus 1, or my bad. it should be white, so, or yellow actually. So minus 1 is less than x, and it's less than 2. Okay, so when you go from the right to the left side, you can have or basically when we're solving this part, so x plus 1 is greater than or equal to 0, x is greater than or equal to minus 1. Okay, you can have, so x in our case is going to be greater than minus 1. You can add the equal sign below. Okay, if you were to solve it, and it would be, for example, less than, so let's say you had minus x here, and you'd get minus x is greater than minus 1, x is less than 1, for example, then you would go from the right side here. Okay, it's a bit of a complicated procedure, but basically you just use the equal sign below when it would be positive. So for example, or is equal to 0 as a valid solution. It doesn't really matter, just use it at least once, okay? You can use it from the left side or the right side, it doesn't really matter. Okay, minus x, so between minus 1 and 2. Then what's gonna happen here? When x is between minus 1 and 2, this one is gonna get a negative sign, and this one will just remain positive. So we're gonna have x plus 1 equals minus x plus 2. So we just change the signs of everything inside the absolute value. And in this case, we're gonna get x equals, or 2x is gonna be equal to 1. X is going to be equal to 1/2, which is in this range. So x equals 1/2 is a valid solution. Okay? And what if they're both negative? Well, if they're both negative, then the minus signs are just going to cancel out. And we're just going to get this again. So this one we can already just say it has no solutions. So the only solution is x equals 1/2. Okay? And yeah, that's how you could solve an equation like this. Let's take another one here and explain it a bit better now, because I know the explanation for the previous one was a bit confusing. So, what we're gonna do, we're gonna write them out in the long form. You could just write zeros, but it's going to be easier to write them just as zeros with practice, but for now, just write the two equations. So, x plus 5 is greater than or equal to 0. X is greater than or equal to minus 5, or x is less than minus 5. And here we're gonna have x minus 1 is, and just like this is meant here, okay? So the other case is that x is less than 5, minus 5. You just switch the sign around. So if you have greater than or equal to, you're gonna have less than. Here we're gonna have x minus 1 is greater than or equal to 0, x is greater than or equal to 1, and the other case is going to be x is less than 1. You write them out here now. So we're going to have 1 here, minus 5 here. Okay? And yeah, let's see. Here we have when x is greater than 1. So when we're going to be on this side, our solution is just going to include this sign as well, okay? And when we're going to be on less than 1, it's not going to include the less than equal to, okay? And when we have here, x is greater than or equal to minus 5, so that's here on the right side. When we're going to be in this range, we're going to use less than or equal to, minus 5 is less than or equal to. And when we're going to be on this side, we're going to be just like here. Okay, so basically you place them from the most right to the most left. So which one is the most right in our case? Well, the most right here is greater than 1, okay, which is this one. So x is greater than 1 or equal to 1, okay? Here we're gonna use this one, Okay, so in this range, we're going to use this one because we've already used this one. So it's not going to be less than or equal to 1. It's going to be just less than 1, x. And then here, we have to use the right. We have to go to the right of -5. To the right of -5 is greater than or equal to. Okay, so -5. And this one is going to be less than -5. Okay, so those are our three conditions. And now let's see each one. So when x is greater than 1, okay, what's going to happen? Well, both of these are going to be positive. So let's say we just choose a random number. Let's choose 2. 2 minus 1, it's going to be 1, so it's going to be greater than. You don't need to put the negative sign in front of it. So x minus 1 is going to be positive. And if we choose 2 here, 2 plus 5, it's going to be 7, so that's also going to be positive. X plus 5, it's going to be positive. Then we went over 1, so this one's going to change signs. So x minus 1 becomes negative, and x plus 5 remains positive. And when we change over to 5, this one's going to change signs as well. So x minus 1 is negative, and x plus 5 is also negative now. Now let's see. When we solve this equation, so when x is greater than or equal to 1, here, okay? We're gonna have 2, and both of them are gonna be positive, so we just remove the absolute values. So 2x minus 1 minus x plus 5 is 1. 2x minus 2 minus x minus 5 is 1. X minus 7 is 1. X is equal to 8, which is greater than 1, so that one is okay. This solution is okay. Now we have when x is between -5 and 1. Less than 1, we're gonna have here x minus 1 be negative, so we have -2 x minus 1 here. While this one is just gonna remain positive, so we're gonna have minus x plus 5. If it were to be negative, this minus would become a plus, okay? So this equals 1 minus 2x plus 2 minus x plus minus 5 is equal to 1. So we're gonna have minus 3x plus 3 be equal to 1, or sorry, minus 3 be equal to 1. And then we're gonna have minus 3x is 4, x is minus 4/3, which is approximately minus 1.3 periodical. And we said that our x is gonna be between -5 and 1, so that's okay. This solution is also okay. Lastly, we're just gonna look at the last case, so when both of them are negative, so x is, x is less than -5. Okay, so we're gonna have -2 x minus 1 plus x plus 5 is equal to 1. We're gonna have -2 x plus 2 plus x plus 5 equals 1. And we're gonna have minus x plus 7 is equal to 1, minus x is equal to -6, x is equal to 6. So when x is less than -5, the only solution is x is equal to 6, which is incorrect. So that would not be an official solution. So the only two solutions we have is x1 is 8, x2 is -4/3. These are the solutions that actually solve this equation. Okay, now moving on, we have this one here. Okay, so here we have an absolute value inside of an absolute value. What we're going to do is the exact same process. First, we're going to see when x plus 1, the inner absolute value, is greater than or equal to 0, and then we're just gonna solve each case respectively. Respectively, sorry. X plus 1, when it's greater than 0, x is greater than or equal to minus 1. Again, we're just gonna write these conditions, so x is less than minus 1. Now let's look at this case. So we're gonna look at x is greater than or equal to minus 1. In this case, this absolute value is just gonna be removed, so it's not gonna have any effect. Okay? If x is less than minus 1, well, x plus 1 would then be greater than 0, so the absolute value would have no effect. So we're just gonna write it like this. Absolute x plus 1 minus x equals 1. Okay? And now imagine that you just got this as the equation at the start. You didn't get this, you just got this equation. You just solve it again in the same way that you would solve any regular equation with only one absolute value. The only thing is, at the end, you're gonna look at only the solutions for which x is greater than or equal to minus 1. Okay? In this case, the x's are just removed, so we have absolute value of 1 is 1. So this is okay. Okay? This is valid for every x that is greater than or equal to minus 1. Okay? So that's our condition. The first one. What about the second one? Well, when x is less than minus 1, this absolute value here, again, we're gonna have to add a negative sign in front of it. So we're gonna have minus x plus 1 minus x is equal to 1. Or if we reduce this or simplify it, is 1 minus 2x minus 1 is equal to 1. Okay? Now, this is our equation. We have to solve this, and then at the end we only accept solutions for which x is less than minus 1. So, yeah, how would we solve this? Well, again, you just look at each case respectively. So when minus 2x minus 1 is greater than or equal to 0, minus 2x is greater than or equal to 1, x is less than or equal to minus 1/2. Okay? And then we're gonna have on the other one, x is, so again, minus 2x minus 1 is less than 0, minus 2x is less than 1, x is greater than minus 1/2. Okay? You just switch the absolute value, or the inequality sign. Okay. Let's look at this one. So here it's going to be positive, here it's going to be negative. So on the positive side, we're going to get minus 2x minus 1 is equal to 1, minus 2x is going to be equal to 2, x is going to be equal to minus 1. Let's look. It has to be, our solution has to be less than 1/2, minus 1/2, which it is. And the original condition also states here that x has to be less than minus 1. So this is a no-go. This isn't a valid solution. Next, we look on the left side here. So x has to be greater than minus 1/2. Here we're going to add a minus in front of the absolute value. So we're going to get 2x plus 1 is equal to 1. Okay? The 1's are reduced. 2x equals 0. X is equal to 0. And x has to be greater than minus 1/2, which it is. But x also has to be less than minus 1, which it isn't. So this is also a no-go. So the only solution that's valid here is anything where x is greater than or equal to minus 1. That one has solutions, the others don't really. But here, curiously, we see that here we got x equals minus 1 as a valid solution, and here we didn't get it, or here we got it as a valid, but here it wasn't valid. So let's check this case specifically. So if we insert minus 1 plus 1 minus minus 1 is equal to 1, these two are going to just be removed, and we're going to have the absolute value of 1 is equal to 1, which it is true. So this one is actually okay. It just, in this specific area, it wasn't okay. The reason for this is because, as we stated, it wouldn't matter how we described the absolute value function. So if we can say that the absolute of x is here x if x is greater than or equal to 0, and minus x if it's less than 0. But it would be also okay if we wrote this, but in this case it wouldn't be really a function because it's, how do you know? Do you use a minus or a plus sign? Doesn't matter. Or if you define it like this, it also wouldn't matter. The thing here was that because we weren't allowed to use the edge case, so this one, C, we had to discard the -1 solution, even though it was perfectly valid. So that's something you have to watch out for. You can always test the solutions to see that they're going to be okay. And yeah, that's basically absolute values and how they work. If you have any questions in the comments, let me know, and I will see you in the next video. Bye.